Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 12 of our unit Laws of Motion. So let's begin with today's class. In today's session, we are going to discuss about the circular motion. So let's begin with today's class. Basically in circular motion, when we discuss the circular motion, we are discussing two kind of motion. One is the uniform circular motion. It's a uniform circular motion that we call it as an UCM, uniform circular motion, and the another is the non-uniform circular motion. It's a NUCM. Yes. So let's discuss what is the difference between uniform circular motion and non-uniform circular motion. Let's suppose this is the situation, that this is the circle, this is the center of the circle. Now suppose your particle is here and it is moving with a speed of 20 meter per second. When it reaches here, its speed is 20 meter per second. When it reaches here, its speed is 20 meter per second. When it reaches here, its speed is 20 meter per second. This could be considered as a uniform circular motion. Come to the conclusion after I will show you what non-uniform circular motion look like. So first look this and have a conclusion that why or which should be considered as a uniform circular motion and what should be considered as a non-uniform circular motion. So let's say this is 10 meter per second, this is 12 meter per second, this is 20 meter per second, this is 8 meter per second, this is 10 meter per second, something like this. So how could I differentiate that which one is or what is requirement for uniform circular motion and what is requirement for non-uniform circular motion? What is coming to your mind? What is it? Yes, that in the uniform circular motion, and this is non-uniform circular motion, in this speed of the particle is always same. That means on throughout the journey. In non-uniform circular motion, speed of the particle changes. When I say changes, I mean it could increase, it could decrease. It could be a both the things, but it is changing for sure. That is for confirm that it is going to change. Next, now the question is, does velocity changes in uniform circular motion? Does it changes? Does it changes? Yes, I must say that yes, velocity of a particle changes. Why? Because direction changes. So velocity changes. Now when I say velocity, I must understand that velocity is a vector form. That means whether direction is changing or magnitude, direction changes. Here, even here, it's a velocity changes. Here direction is changing. That's why it is called as a circular motion. And magnitude is changes. So here both are changes. Even velocity is changes, and that means direction as well as magnitude. Both things are changes when I'm talking about the NUCM. I'm talking about the non-uniform circular motion. Is it clear? Is it clear? So one more important difference It's as UCM, non-uniform circular motion. Only one force is required, which changes the direction of particle, that we call as a centripetal force. We are going to see this, what centripetal force is, but only one force is required. While talking about the non-uniform circular motion, a centripetal force is required to change the direction and tangential force is required to change the speed of a particle. We are going to see this in detail, that how the direction can be changed and how the magnitude, that means the speed, can be changed. But just do remember these things. This is the basic difference between uniform circular motion and non-uniform circular motion and all this kind of stuff. I hope this is clear. Is it clear? So now let's begin with the basic terminologies. Of circular motion. First, it is angular displacement. It's an angular displacement. What is it? Let's understand that this is a circle, this is its center, this is its arc, and this is A, and your particle has started its journey. From here, and it reaches to here. This is point B. So even arc can be made from here. So from A to P, this displacement can be measured in theta, and SI unit of angular displacement is radian, generally denoted as R or RAD. Yes, and this is a unit. This is a unit which does not have any dimensions. If you remember this, we have discussed about the radian and steradian, yes, for the plane angle and solid angle in the unit number 2, units and dimensions. Yes, so this is a unit which does not have any dimensions, and its SI unit of angular displacement is radian. Let's look at the second, very important. It's an angular velocity, generally denoted as omega, and angular velocity omega is angular displacement . divided by time. The angular displacement can be denoted as theta. So this omega could be written as theta by time. Yes, omega is equals to theta by time. If I go for the unit, it's a radian per second. If I go for the dimensional formula, the radian does not have any dimensions, but second does have. It's an m0 l0 t minus 1. This is omega. It's an angular velocity. I hope this is clear. Yes. Direction of angular velocity. Direction of angular velocity is perpendicular to the direction of plane of circular path. Remember this. We are going to discuss in more detail, but at this point of time you must remember this. This is omega is equals to theta by t, and its direction is perpendicular to the direction of plane of circular path. Yes. Now let's just assume that, let us suppose a particle completes one circle in time that I denote by capital T. Then this is the situation. This is the circle. A particle must have started from here, and while moving in this direction it has completed it. It has reached to A, and then omega can be written as theta divided by time t. The theta, it has completed a one circle, and while I say one circle, it is 360 degree. The time taken is t. This is 2 pi divided by t. If you remember the 8th or the 9th class, it's a 2 pi divided by 1 by t. This 1 by t is the frequency, so this is 2 pi f, and this time t is the time period. While I write time period, I always mean it is the time required to complete one circle or one revolution. Yes, it is the time required to complete one revolution. Always do remember one thing. Yes, so if you have been mentioned small t, that means it could be any time, any instantaneous time could be that. But when it would be in capital T, it is denoting time period. And while I say it's a time period, I mean it is a time required to complete one revolution. I hope this is clear. Is it clear? Is it? Great. Now let's talk about the directions of omega that we have discussed up till now. Let's talk about the direction of the omega. So the situation is, let's suppose this is the circle and your particle is at here and it is moving in this direction. That means it is moving in the anti-clockwise direction. It is moving in the anti-clockwise direction. So direction of omega can be determined using right hand rule. So curl your fingers in the direction of force then thumb will represent direction of omega. So according to the situation, if particle is moving in this direction with speed omega, then omega, as it is moving in the anti-clockwise direction, if you curl your right hand fingers in the direction of motion, then you find that omega is outside the plane. It's a plus k cap. Yes, for the motion of anti-clockwise. For the motion of anti-clockwise. Yes. Now let's suppose if particle is moving in the clockwise direction. Particle is moving in the clockwise direction, something like this. Then omega should be is equals to minus of k cap. If particle is moving in the clockwise direction. So even you can remember this, that if particle is moving in clockwise, it is minus of k cap if I have considered my plane of motion in x and y direction. So if it has been considered that my particle is moving in the xy plane, then omega could be in plus k or minus k. When plus k, when it is moving, when particle is moving in anti-clockwise direction, and when particle is moving in the clockwise direction, that would be equals to minus of k cap. I hope this is clear. Is it clear? Great. Now let's work for the next situation. This was the omega. Now let's discuss the next terminology, that is of angular acceleration, generally denoted as alpha, and this acceleration alpha is equals to change in angular velocity divided by time. Change in angular velocity, let's suppose denote it as a delta omega. So alpha could be written as delta omega divided by time t, or this change can be represented as omega minus of omega naught, that is divided by time t, where omega is the final angular velocity, while the omega naught, it is the initial angular velocity. So this is omega naught, final angular velocity and initial angular velocity. It's their unit. This is omega naught. This omega, it's radian per second. For time, one more second would be there. It's a radian per second square. This is its SI unit. Let's work for the dimensions. It's an m0, l0, t to the power minus of 2. This is the dimensions of alpha. Yes, directions or direction of alpha. The direction of alpha can be calculated in same manner as omega. Yes, you can calculate direction of alpha, or you can determine the direction of alpha as you can determine the direction of omega. Basically, these are the axial vectors. We can say so. It's an axial vectors that are the, even this are some of the authors mention them as, and these are the rotating vectors. Yes, so these are the radial vectors, axial vectors, and this kind of names has been given to them. Yes, plus do remember this thing. Are you clear with this? Any difficulty in this? Is there anything? Is there? No? Okay, great. So let's just relationship between linear quantity and and angular quantities. Let's have a relationship between linear quantities and angular quantities. That let's begin with theta and angular displacement. The situation was something like this. Was the circle, and this was the angle theta. This is what we call as a radius, and this A, this B. This is what we call as an arc. So in geometry we have a relation that theta is equals to arc divided by radius. From this, let's suppose arc is denoted by L. This is denoted as R. So this L is equals to R into theta. This is the first relation that relate linear quantity and angular quantity. This is the first relation. It's L equals to R theta. Now let's just differentiate this. It's R multiplied by d by dt of theta. So dl by dt, it's a length by time. We could write this as a velocity. This is equals to R into d theta by dt. This is the angular displacement divided by time, that we call as an omega. So this is equals to V is equals to R omega. Very important relations. Please do remember this. It's a V is equals to R omega. Now we have this relation, that is V is equals to R into omega. Let's again differentiate this. It's a d by dt of V, that should be equals to R into d by dt of omega. Now dv by dt, a change in velocity with respect to time. What is it? Change in velocity with respect to time. What is it? Yes, it's an acceleration. Generally we call it as an AT. It's a tangential acceleration. It's a tangential acceleration. Should be is equals to d omega by dt. This is R. D omega by dt, it's alpha. So this is very important relation. It's an AT is equals to R alpha. Yes. So we have three relations that can relate angular world and linear world. Yes, the first relation is L is equals to R theta. The second relation, that is of V is equals to R omega, and the third relation, it is AT is equals to R alpha. So is it clear up till here? Is it clear? Great. So let's have a look to the question, because it was a long theoretical session of 23-24 odd minutes, so it is required. Let's have a question. Be ready with your pen and paper. Do it fast. That find out angular velocity of second hand. Yes, we are talking about the clock. Yes, in the clock 3 hands would be there. I'm talking about the second hand. So what I required, it's an angular velocity of second hand. So what I can have, it's omega is equals to 2 pi by t. This is equals to 2 pi divided by second hand revolves on clock in a circular motion within a 60 seconds one revolution would be completed. So this is 2 pi by 60, and when I write 2 pi by 60, it's a pi by 30 radian per second. Same way, second and minute and hour and. So this was first. Now second, for minute and, it's omega is equals to 2 pi by t. It's a 2 pi divided by minute and what does it take to complete one revolution? Yes, it's a 1 hour, and 1 hour, that means 60 seconds, 60 minutes. So this is equals to pi divided by 2, 30 is a 60. So 3 6 are 18. It's a pi divided by 800 radian per second. Is it clear? Is it clear? Great. Let's look at the third question about the R end. So the omega is equals to 2 pi by t. This is equals to 2 pi divided by. Now what would be the time required to complete one revolution? Please do remember that it is the 12 hours that will require to complete one revolution for the R end. Yes, in general sense, I have seen students making a mistake that they are going to utilize by 24 hours. Please do not commit this mistake. You must understand that R end completes one revolution in 12 hours, or you must understood that R ends completes two revolutions in one day, that is of 24 hours. Yes, even 6 o'clock would be there on morning as well as in evening. I hope this is clear. Do not commit this mistake, please. It's a 12 hours multiplied by 60 multiplied by 60. So this is pi divided by 6 into 3600 radian per second. I hope this is clear. Is it clear? Any issues in this? Anything? Any doubts? No? Great. Now let's just move to the next question. If a particle is moving on circular path having radius of r is equals to 2 meter, please excuse me, a particle is moving on a circular path having radius of r which is equals to 2 meter with a speed of 10 meter per second. Find out its angular velocity and angular acceleration. This is required. Do it yourself and do it fast. Yes. Did it? Have you? Okay, let me help you. What is given? the velocity, sorry, speed is given, and that has been given as a 10 meter per second. Even a radius is given. So r, 2 meter, velocity, or I should say it's a linear velocity, is given, it's a 10 meter per second. What I required, it's an angular velocity. So angular velocity and v and r, does it have any relations? Yes, it do have it. So v is equals to r into omega. This v, it's a 10 meter per second. R, it's a 2. Omega is required, and omega is 10 by 2, which is a 5 radian per second. I hope this is clear. Is it clear? Great. Now, what about the angular acceleration? What about the angular acceleration? Yes, as I can see that omega, which is an angular velocity, is not changing. That angular velocity is fixed, or it is not changing. So angular acceleration alpha would be equals to 0. Yes, as acceleration, if someone asks me what would be the acceleration of this system, then I will definitely look for the velocity. It is basically a change in velocity with respect to time, as velocity is fixed, so it is not changing. Acceleration is 0. Same way you are going to consider this, that my angular velocity is not going to change. It is fixed, and when it is fixed, my alpha must be 0. I hope this is clear. Is it clear? Is it? Great. Now let's work for the next question. Let's suppose two concentric circles are there, and this one is R1, this one is of R2. Yes, they have given that R1 is of 1 meter, R2 is of 2 meter. Yes, two particles are there. This is particle A, this is particle B. Both are having same angular velocity. Then what I want? Find out ratio of first, that time period, which should be at t1 is to t2. Second, the velocity, that means I'm talking about the linear velocities. Great. So let's begin. What is given? The given data is omega 1 is equals to omega 2. This is given, omega 1 is equals to omega 2. So what I can have, it's a 2 pi by t1, that should be is equals to 2 pi by t2. This is 2 pi by t1 divided by 2 pi by t2. This 2 pi has been gone, and when this has gone, it's a t1 is to t2, that should be is equals to 1 is to 1. I hope this is clear. Is it clear? Yes, very good. Now let's just work for the v1 is to v2. So it's a v1 is to v2, that should be is equals to r1 by r2 multiplied by omega 1 divided by omega 2. R1, it's a 1, R2, it's a 2, multiplied by omega 1 divided by omega 2, it's a 1 is to 1. So this is equals to 1 by 2. This is the velocity. It's a v1 by v2. And time period, time required to complete one circle would be the same. I hope this is clear. Is it clear? Are you sure? Are you sure? Great. Let's look at this question. A very good question. Let's have a look very carefully. That this is the circle, and this is the center of the circle. These two are the diametrically opposite points. Let's denote it as A and let's suppose this is B. Yes. Now let's assume that there is certain particle that is P over here, and suppose we connect this C to P and we connect this A to P. Now one thing I understand is that AC and CB are equal because C is the midpoint. Yes, that we understand. So if omega with respect to A, omega at position A is omega radian per second, then find out omega with respect to C. This is required. So how can you do this? Now what I understand is that omega is equals to theta by time t. So let's suppose time is the same. If this distance, that is the distance AC, and the distance CB are equal, if distance AC and CB are equal, that means this angle theta and this angle theta should be equal. Yes, these two angles must be equal because this distances are equal. And if this distances are equal, this is angle theta. So the situation is something like this. If you understand this, it is something like this, that this is theta, even this is theta. So for this triangle, it's a triangle ABC. This angle will be the exterior angle, and this exterior angle will be having a value of theta plus theta, which should be equals to twice of theta. So that could be omega at A, that should be is equals to theta by t. Omega at C, this is twice of theta by t. So let's have a ratio. It's a omega A is to omega C. This is equals to theta by t multiplied by this is twice of theta by t. This has been gone. This theta has gone, and this is 1:2. If I mention omega A as an omega, so this is omega by omega C. This is equals to 1:2. So omega C should be equals to twice of omega. A very good and very logical question. This is a multiple concept question in a true sense, because for this you need to understand that if these two are equal, this angle and this angle must be equal. A first question or a first concept of geometry. Second concept, that for a triangle, the exterior angle will be having a value of addition of their interior angles. Yes, so please do remember this. Very good question and very logical. Now let's just see the similarities between linear relations and angular relations. So let's just start it with calculus. That means differentiation and integration. For the linear world, I can write like this. It's a v that is equals to dx by dt. For the angular world, what I can write, it's a omega that is equals to d theta by dt. First, for the acceleration, I can write it's a dv by dt. For this, it's an alpha that could be written as d omega by dt. I hope these things are clear. I hope you can compare this. This is velocity. This is angular velocity. This is displacement. This is angular displacement, and this is with respect to time. Again, this is acceleration. This is angular acceleration. This is velocity, or I should say change in velocity. This is change in angular velocity with respect to time. So this is how they are just a replica of each other. that when and when I used to have a linear world, I can have acceleration is equals to dv by dt. But at the same time, when I am having the angular world, I can have alpha is equals to d omega by dt. One more relation, it's an a is equals to v dv by dx. A same way alpha could be written as omega multiplied by d omega by d theta. Is it clear? Is it clear? Yes. So this were the differential calculus relations that were relating the linear world and angular world, or similarities. Yes. Now let's just look the integral calculus. We are talking about the integral calculus. So for integral calculus, what I can have is the first, it's a x is equals to integration of v dt. Same way here, theta should be is equals to integration of omega dt. Second, here v is equals to integration of a dt. Here it could be written as omega is equals to integration of alpha dt. So these are the integral calculus that we can relate. Even we can have this relations that integration of dv by dx or integration of dv. We have basic sorry, we have this relation a is equals to v dv by dx, and from this integration of a dx could be written as integration of v dv. This is important because even this will give the change in velocity or square of the velocity. From this you can reach to the kinetic energy. A is equals to v dv by dx. Same way alpha is equals to omega into d omega by d theta. So alpha into d theta, or integration of alpha into d theta, could be written as integration of omega into d omega. So this is how they are similar. Now again in similarity, we are discussing the similarities in kinematics equations for uniformly accelerated or uniformly angular accelerated motion. So here in the linear world, I can write like this. It's a v is equals to u plus at. In the angular world, I can write like this. It's omega is equals to omega naught plus alpha into t. Here I can write it's a displacement x is equals to ut plus half at square. Here in the angular world, I can write it's a theta, that should be is equals to omega naught t plus 1 by 2 into alpha into t square. Here I can have it's a v square is equals to u square plus 2ax. Here it's a omega square, that should be is equals to omega naught square plus 2 alpha theta. So these are the relations. These are the relations which are very helpful to get our task done. I hope this is clear. Is it clear? Is it great? So ready for the numericals? Are you ready? Let's have a look. Question that if angular displacement of a particle is given as theta is equals to t cube plus 4t square plus 90, sorry, it's a t, 9t minus of 18 radian. Find out first angular velocity at t is equals to 2 seconds. Second, angular acceleration at t is equals to 3 seconds. So let's work for it. First, for angular velocity, theta is given. What I want an angular velocity. So it's an omega, which should be is equals to d theta by dt. This is equals to d by dt of theta. This is equals to theta is given. Theta is given, that is of t cube plus 4t square plus 90 minus of 18. So if I differentiate this with respect to time, what I can have, it's a t cube that is equals to 3t square plus 4t square. It is of 8t plus 9, and minus of 18 would convert to a 0 because differentiation of any constant would be a 0. So this is the omega with respect omega related with time. Now what I want omega at t is equals to 2 seconds. This is instantaneous angular velocity. In the third unit, motion in a straight line, we used to calculate instantaneous velocity, but in true sense it is instantaneous linear velocity. Yes, so let's just put up the value of time. It's a 3 into 2 square plus 8 into 2 plus 9. It's a 3 4s are 12 plus 8 2s are 16 plus 9. 16 plus 9, 25 plus 12. It's 37 radian per second. I hope this is clear. Is it clear? Great. Now let's just calculate the alpha. So for that I required an omega. What is it? It's a 3t square plus 8t plus 9. Now alpha, which is equals to d omega by dt, this is equals to d by dt of omega, and omega can be written as 3t square plus 8t plus 9. That should be is equals to 3t square, which is 60 plus 8. At what instant? I required an alpha at t equals to 3 seconds. So this is equals to 6 3s are plus 8. That should be 18 plus 8, which should be 26 radian per second square. That's it. Got it. I hope this is clear. Is it clear? Is it clear? Great. So these things can be done very easily. Yes, if I can relate linear world and angular world, then these things are much easier. I hope this is clear. Is it clear? Okay, let's look at one more numerical. That angular acceleration of particle is given as alpha is equals to 4t plus 2 radian per second square. Alpha is equals to 4t plus 2 radian per second square. Find out angular velocity for t is equals to 0 to t is equals to 3 seconds. So alpha is given. Alpha is equals to 4t plus 2 radian per second square. What I need to find out the angular velocity for t is equals to 0 to t is equals to 3 seconds. So alpha is given, angular velocity is required. Angular velocity could be written as integration of alpha into dt. So that should be is equals to integration of 4t plus 2 into dt. Starting from 0, ending at 3. In a true sense, this is delta omega. This is change in velocity. But let us assume that initially it is at rest, and then I need to find out the omega. So if I integrate this, it's a 4t square by 2 plus 2t from 0 to 3. This is equals to 4t square by 2. It is a 2t square plus 2t from 0 to 3. This is equals to 2 into 3 square plus 2 into 3. This is 2 9s are 18 plus 6, which should be 24, which should be at 24 radian per second. I hope these things are clear. Is it clear? Is it? So can you do this? Can you? Yes. Is it possible? Yes. Are you sure? Great. Let's look at the next question. A wheel was or is initially at rest and it starts moving with angular acceleration of it starts moving with angular acceleration of 2 radian per second square. Find out first. Find out first angular velocity at t is equals to 10 seconds. Second, angular displacement in t is equals to 5 seconds, and number of revolutions in t is equals to 5 seconds. So what all is given? Go through the data once and just identify what is given and what is need to be solved. It says a wheel is initially at rest. That means the initial angular velocity omega naught is equals to 0 is given. Then it starts moving with an angular acceleration of 2 radian per second square. It's an alpha which is given. It's a 2 radian per second square. What I want an angular velocity at t equals to 10 seconds. So omega could be written as omega naught plus alpha t, in which 0 plus alpha, which is of 2 radian per second square, multiplied by time, that is of 10. It's a 2 into 10. This is a 20 radian per second. This is your omega. Omega it is equals to 20 radian per second. This is the first. I hope this is clear. Next, a second. Angular displacement theta is equals to omega naught t plus 1 by 2 alpha into t square. So that should be equals to 0 plus 1 by 2 multiplied by alpha. Alpha is of 2 radian per second square multiplied by t square. The time, that is of 25 seconds. This has been gone and this is 25 radian. I hope this is clear. Third, number of revolutions n. N could be written as theta divided by 2 pi. Yes, this is equals to 25 divided by 2 pi. This many revolutions has been passed, or this many revolutions has been gone while moving for 5 seconds. I hope this is clear. Is it clear? Is it? Any doubts? Anything? No? Great. Let's work for the next question. That a wheel is rotating at angular speed of 240 rpm. This is revolutions per minute. Is rotating at angular speed of 240 rpm, comes to rest after traveling for 10 seconds. Find out first angular displacement and second number of revolutions. So these two things are required, and what I have given, omega is given and time is given. It's an initial velocity, yes, initial angular velocity. Now first thing, can I deal with rpm directly? No. What is need to be done? That needs to be converted. Now how should I convert it? It's a 240 rpm, revolutions per minute. So that needs to be multiplied by 2 pi by 60 multiplied by 240. Then it will become a radian per second, because one revolution stands for 2 pi. It's a 360 degree. And per minute, if I required for per second, I need to divide it by 60. So this is 60 fours, and that should be is equals to 8 pi. Do remember this. It's a 2 pi by 60 to convert from rpm to radian per second. So the omega that is given, that is the 8 pi radian per second. Time, this is omega naught actually. This time is of 10 seconds. What I want the angular displacement theta, and I want number of revolutions. Even I need to calculate alpha for this. So it's an omega is equals to omega naught minus of alpha t. They said it comes to rest. This means the final velocity is 0. This is 0. This is equals to 8 pi minus of alpha that I don't know. Time is of 10 seconds. So alpha is equals to 8 pi divided by 10. It's a 4 pi divided by 5 radian per second square. Again, this is retardation, so this could be written in minus. Now theta, it's a omega square minus of omega naught square should be equals to 2 alpha theta. This is 0. This is 8 pi square. It's a 64 pi square should be equals to 2 into alpha. It's a 4 pi by 5 into theta. Even this would be negative because alpha is negative, so minus has gone, and this is equals to, it's a 4 pi, it's a 64 pi square, so this is 16 pi would be left. So theta would be equals to 16 pi multiplied by 5 divided by 2. It's a 8 pi, so this is equals to 40 pi. This is theta. It's a 40 pi radian. Now I have been left with the number of revolutions. So the number of revolutions n would be equals to theta divided by 2 pi. This theta would be equals to 40 pi divided by 2 pi, and this number of revolutions would be 20 revolutions. So I got everything what I required. I hope this is clear. Is it clear? Are you sure? Are you? So can you do this? Can you do this? Are you sure? Great. Now let's work for the next question. If angular acceleration of wheel is given as alpha is equals to 4 theta radian per second square. Alpha is equals to 4 theta radian per second square. Find out angular velocity when theta is equals to 4 pi. Assume that initially wheel was at rest. So look at this very carefully, because alpha is equals to 4 theta is given. Is there something that is unobvious? Yes, it is alpha, because here alpha is not constant, it is variable. And when alpha is variable, I cannot use the relations that were built up or that will be constructed for the uniform acceleration or uniform angular acceleration. So what I need to do is that alpha is related with theta, it's an angular displacement. So I have two relations of the alpha. One of them was the d omega by dt. Alpha is equals to d omega by dt, and the another was alpha is equals to omega into d omega by d theta. Alpha is equals to omega into d omega by d theta. So what I need to do is I need to just go with this relations and try to get it done. So let's just try it. It's an alpha that should be is equals to omega into d omega by d theta. So alpha into d theta, that should be is equals to omega into d omega. Let's just integrate this. This alpha is equals to 4 theta into d theta, from theta initial to theta final. Even this is omega d omega, from omega naught to omega final. Yes. So this is 4 theta d theta. This is equals to 4 into theta square divided by 2, from theta initial to theta final. This is equals to omega square by 2, from omega naught to omega final. So this is 2 into theta square, from theta initial to theta final. That should be is equals to 1 by 2 multiplied by omega final square minus omega initial square. So this is equals to 2 into theta final. Theta final, it's an theta final, that means it's a 4 pi. So 2 into 4 pi square minus of 0 initial should be equals to 1 by 2 into omega f square, as omega I square was 0, that is provided in data. So this is 2 into 4 pi square, it's a 16 pi square, should be is equals to half into omega f square. So this is 2 2s are 4, 4 into 16s are, so omega f square, it's an 4 into 16, it's a 64 pi square, and omega final, it would be an 8 pi radian per second. I hope this is clear. Is it clear? Is it? Yes, a very good question. Yes, only one thing that you should understand very quickly is that this is the variable angular acceleration, and when variable angular acceleration is there, I could not go with the normal situation. That means if you have think that I could use omega square minus omega naught square is equals to 2 alpha theta, then this is your mistake. You should not go with this. Yes, because alpha is variable. Because alpha is variable. Yes. Is it clear? Is it? Do you understand each and everything, or any confusion? Is there anything? No? Great. Let's work for the next questions. Let's work for it. So, what is given? What do I require? Let's have a look. Do it quickly. Let's suppose alpha is equals to 5t radian per second square. Find out change in angular velocity from t is equals to 0 to t is equals to 5 seconds. So alpha is given, that is equals to 5t. It's d omega by dt, that should be is equals to 5 into t. So d omega could be written as 5t dt. When this has been written, what I can have, it's integration of d omega is equals to integration of 5t dt. This is change in angular velocity. That is what I require. It's a 0 to 5. So this delta omega should be equals to 5 into t square by 2. That should be is equals to 5 by 2 multiplied by it's a 5 square minus of 0 square. So that should be is equals to 5 by 2 multiplied by 5 square. This is 25. 25 5 it's a 125 by 2 radian per second. Good and great job. So I hope you can relate these two worlds, yes, a linear world and the angular world, and make things easier. Is it clear? Okay, now let's again look at the new dimensions of the circular motion. That now again we will back with the uniform circular motion that we have begin at a very beginning. We were discussing this. It's a uniform circular motion. So let's have a look. That this is a circular path in which particle is moving, and this is the radius r. This is the radius r. Let's suppose a particle is moving in this direction. Let's suppose particle is moving in this direction. So a tangent to it will give me the direction of velocity. Position vector always represents from the origin. That means in circle we understand this as from the center. So r would be in this direction, and as we have discussed the centripetal acceleration, that centripetal acceleration always acts towards the center of the circle. It's an AC, something like this. So AC centripetal acceleration, it's an, if you remember the centripetal force, that Fc could be written as mv square by r. That could be written as m into AC. This mass has gone, and the centripetal acceleration would be equals to v square by r. This is centripetal acceleration. Centripetal acceleration acts towards center of circle. This acts towards the center of the circle. Is it clear? Is it clear? This is uniform circular motion, because you need to change the direction of a particle each and every instant. And when you require to change the direction of particle on each and every instant, that means a certain force is required to change the direction, and that force is centripetal force. Now let's just find it out the angle between certain parameters, that position vector r and linear velocity v. They are related with each other by pi by 2. Yes, 90 degree. Angle between r and centripetal acceleration. Yes, look at this. They are related by pi 180 degree. AC centripetal acceleration and velocity vector v, they are related by 90 degree. It's a pi by 2. One very important, AC and omega. What is it? Angular velocity omega. What is the angle between AC centripetal acceleration and angular velocity? Yes, if you observe this very carefully, then you must understand that this AC is in this direction. It's a minus of I cap. Yes, and omega as now this is moving in the anticlockwise direction, it is in plus k cap. So AC and omega having an angle of pi by 2. Again, I hope these things are clear. Is it clear? Is it clear? Are you sure? Are you? Any difficulties? Anything? Anything? No? Great. Next, let's work for the non-uniform circular motion. Non-uniform circular motion. So in this situation, let's say this is the circle on which particle is moving. This is the center of the circle. This is the position of the particle. Now this is position vector r, this is velocity vector v, this is centripetal acceleration AC. Yes, one more thing, non-uniform circular motion. Did you remember the very beginning of this session, a very beginning? Yes, we said that in non-uniform circular motion, two things is to be done. One is to change in direction. One is the change in direction. Another is change in magnitude. Yes, these two tasks were required. One, it's a change in direction. Another task, it's a change in magnitude. Change in direction, who will perform this? It's a centripetal force. Where does it act? It's towards center of circle. Change in magnitude, who will do this? Who will do this? It's a tangential force. And where does it act? It acts towards the tangent of the particle or tangent of the circle. Yes. Now, one very important thing. What is the magnitude of centripetal force? It is mv square by r. What is the magnitude of tangential force? Ft. It is a change in speed that we can understood. It's a dv by dt. Yes. So we have, or we must have, two forces that can play a role while I am talking about the non-uniform circular motion. So in this situation, I have already drawn the AC. It's a centripetal acceleration. Now, what about the tangential force? It always acts tangent to the circle. It could be in this direction. That means if I denote it as an AT, or it could be in this direction. Either of this situation could be there. I hope this is clear. Is it clear? Is it clear? Any doubts? Anything? Any doubts in this? Is there anything? Is there? No? Great. So, in this case, there are two situations in non-uniform circular motion. One is the of particle. Speed of particle is increasing. So if speed of particle is increasing, then according to this, the situation must be something like this, that this is the circular path on which particle is traveling. This is my particle. This is position vector r. This is AC. If this is v and speed is increasing, that means AT or tangential acceleration must be in this direction. So it means AC is in this direction, AT is in this direction, a resultant of this two acceleration must be in this direction. I hope this is clear. So if you observe this very carefully, this must be the direction of A, and this must be the angle between A and V, and this theta is acute angle. I hope this is clear. Is it clear? Now let's just find out the angles. And do it quickly. Now you know what is needed. It's an R and AC. This is R, this is AC, this is pi, 180 degree. R and AT. It's a pi by 2. Great. AT and AC. It's a pi by 2. AT and omega, again pi by 2. A and velocity, it is somewhat acute. We cannot have a exact value for every situation. If data has been given, that can be calculated, but on a normal sense, it is the acute value. I hope rest of the things you can do it. Yes, this is the case. When speed of particle is increasing. Is it clear? Any doubts on this? Is there anything? No? Great. Now let's just look that when speed of particle is decreasing, so the situation is, this is the circle, this is the radius, and this must be the position vector r, this must be the AC. Let's say this is v. Now in this situation, speed is decreasing. That means AT must be acting opposite to the velocity. So the situation is, this is AC, this is AT, that we call as a tangential acceleration, and this must be the A, or resulting acceleration of AC and AT. So if this is A, this is the acceleration A, this must be the angle, between V and AC, and as you can observe it very clearly, that this is the obtuse angle. I hope this is clear. So let's just again check it out, all the angles. It's an R and AT. It's a 90 degree pi by 2. It's a R and V, R and V, yes, it's again 90 degree. It's an R and 80 and omega. Yes, the three are mutually perpendicular to each other. Even you can add V as well. Yes. Now V and 80, this is required. This V and 80, yes, they are at pi degree. They are at pi degree. And very important, V and A, it is somewhat obtuse. This is very important. This has been asked. This is V and A. It is an obtuse angle. Yes, I hope this is clear. This is clear. Is it clear? Is it? Now, so we know now the angles, that what would be the angles between V and A and everything. Now, to find out net force acting on particle when it is moving on a circular path, having change in speed. How could I do this? Just follow the basics and the things will be done. Yes, let's suppose this is the particle that is moving on non-uniform circular motion. And when I say non-uniform circular motion, that means I say it that it is the particle which changes its speed. So let's suppose this is V, this is Fc. Let's suppose at this instant speed is increasing, this is Ft. So this is the force F acting. If you observe this carefully, that this Fc and this Ft both are perpendicular to each other. This Fc, centripetal force, and tangential force are perpendicular to each other, and when they are perpendicular to each other, that means this F net could be calculated as root of Fc square plus Ft square. Fc could be calculated as mv square by r, and Ft could be calculated as dv by dt whole square. This is F net. I hope this is clear. Yes, it is true for every time. That means if speed is increasing, you can use it. Even if speed is decreasing, you can use it, because Fc and Ft, they would be perpendicular always. Yes, and as they are going to square it, we are going to square it, that means it would be always a positive value that is coming out. I hope this is clear. Is it clear? Is it clear? Great. Now let's work for the numericals. Yes, we are just going to end this session within few minutes. So please be very careful, because it was not possible to divide this session into 2 or 3 parts, because in that situation the concepts has been leaked out. Yes, so please, I understood that this is a long session, but please manage to do this. Yes, let's have a look to the question, that a particle is moving on a circle having a radius of 5 meter with a speed of 10 meter per second. Find out force acting on particle, mass of particle, mass of particle is 1 kg. So when we came through our questions, first thing what I need to ask is whether it is an UCM, it's a uniform circular motion, or non-uniform circular motion, because examiner is not going to tell you that this is uniform circular motion, go with this, and this is non-uniform circular motion. No, it is not the case. So they are not going to tell us directly that this is UCM or this is NUCM. So what I need to understand is first I need to check that whether it is a uniform circular motion or it is a non-uniform circular motion. How could I check it? So I must understand that if my speed is changing, it is the non-uniform circular motion. But if my speed is not changing, it is uniform circular motion. Here a speed is given that is of 10 meter per second. So this is a case of UCM. This is the case of uniform circular motion. Yes, so when it is a uniform circular motion, I could have it's an Fc is equals to mv square by r, because only one force would be there, and when only a single force is acting, it is the total force acting on this. It's a mass 1, velocity it's a 10 square, divide by radius it is of 5, so this is equals to 100 divided by 5, and that is of 20 Newton. I hope this is clear. Is it clear? Is it great? And where does it act? It acts towards center of circle. It acts towards the center of the circle. That's it. You did it. Great job. Well done. Now let's work for the next question, that if a particle is moving on a circular path having radius 5 meter with speed of 10 meter per second, if the speed is changing at a rate of 10 meter per second square, find out force acting on the particle. So go through data one more time. Go through data and observe this and feel this very carefully. So what the data is saying, that particle is moving on the path having radius, this is 5 meter, with a speed of, that is v, 10 meter per second. And if the speed is changing, that means this is the case of non-uniform circular motion. It is the case of non-uniform circular motion. Assume that mass is of 1 kg. So mass is given, it is of 1 kg, and if the speed is changing, that means at is given, that is of 10. So while it is the case of non-uniform circular motion, in the NUCM I need to go for the FC, I need to go for the FT. FC can be considered as a mv square by r, that is equals to mass is of 1 kg, velocity is of 10, it's 100, divide by radius is of 5 meter, so it's 100 by 5, which is equals to 20 Newton. And Ft, it's m into dv by dt. The m mass is of 1 kg and dv by dt 80, that is of 10. This is equals to 10 Newton. Now Fc is acting in this direction, Ft is acting in this direction, my velocity was in this direction. I understood this because I know that the speed is increasing, and as speed is increasing, F net could be written as root of Fc square plus Ft square, and this could be equals to 20 square, which is equals to 400, 10 square, which is equals to 100. This should be root of 500 Newton. Yes, it's a 25 into 20, or I could write this as, yes, it would be the correct, or something like this. It's root of 5 into 100, that is equals to 10 root 5 Newton. This is F net. This is F net. I hope this is clear. This is clear. Is it? Any doubts on this? Anything? No? So shall I add something to this question? The previous question. Find out. Angle between velocity vector and acceleration. So in previous, I calculate F net is equals to m multiplied by a net. The F net was 10 root 5, mass was 1, so acceleration a net, or the a would be equals to 10 root 5 meter per second square. What was my velocity? Let's just check it out. The velocity was 10 meter per second. Yes, here it is. Velocity, yes, it's a 10 meter per second. So velocity is 10 meter per second. So if I draw the situation, it is something like this. This is the circle. This is the velocity vector. This is the acceleration vector. Yes, this is AC, and this must be the AT. Let's assume that this is the angle theta. So if I make a triangle, this would be the 90 degree. If this is AC, this must be AC. Yes, so I can have, it's a tan theta, that should be is equals to AC by AT. Yes, even you can have this as a tan theta is equals to AC, and this AC and AT. Yes, because AT and V both are the same. So AC, it's a 20, AT, it's a 10, it's a 2. So this tan theta would be equals to 2, and this angle is acute angle. Yes, theta is equals to tan inverse of 2. I hope this is clear. This is clear. Yes, so let's just find it out, this session over here. Please revise this thoroughly. This is the circular motion part 1. We have been left with the circular motion part 2, and that we are going to cover the all the topics regarding and related with the circular motion that has been covered in NCERT in laws of motion. If you are reading NCERT, then this session or this all topics would be covered in motion in a plane. But I have covered it every circular motion in this laws of motion. I hope these things are clear. Yes. So please revise this thoroughly. Please do as many questions as possible, because only questions and the practicing of it and revision of these things can help us and can save us. I hope these things are clear. Is it clear? So practice at least 50 to 60 questions from first session, and then only you will be confident enough for the circular motion. Thank you. Have a good day. Take care.